Right here we're using the zero product property to solve each equation. What the zero product property says is that if you multiply two things together, and you are multiplying two things together here, you're multiplying this binomial with this binomial. And if you multiply two things together and the result is zero, the product is zero, that's why they call it the zero product property, then one of the two things that you multiply together must have been equal to zero. Okay, so either one of these things could have been equal to zero in order to get us zero as a product. So we could say 4k plus 5 could have been equal to zero. And then we need to solve to find out what the k value would be that would make that expression zero. Say minus 5, 4k equals negative 5. And then we're going to divide both sides by 4. And we get k is equal to negative 5 over 4. And what we're saying here is if in this expression we plugged in negative 5 over 4 everywhere we saw k, then the first binomial would turn to 0. The other one wouldn't. The second one wouldn't. Negative 5 fourths plus 7 won't equal 0. But it will in the first binomial, and that's enough for it to turn the whole thing to 0. So we can then say, okay, so then what happens, what about the second one? What if we took the green one, k plus 7, and set that equal to 0? What's another number that will result in 0, another value of k that will result in 0? And we find that it's negative 7. Okay. What we're saying is there are two numbers, there are two x values, or k values in this case, that will give you an output of 0. Both of these numbers, when plugged in, and you can try it, will result in 0 for the product. And because there's two different values, that correlates with the graph. If you were to graph this, if you foiled this together to get the trinomial, and then you graphed it, you would see the graph, the parabola that it makes, cutting through the x-axis at negative 5 fourths and at negative 7. Okay, because those are both places where the output is 0. And so when is y 0? All the points that are on the x-axis. So these will be the places on the x-axis where the curve goes through it. Okay, so that's the idea. We're going to keep going, taking each piece. Now, let's look at this next one. What's being multiplied? Well, what's being multiplied is this negative 3n and this 2n minus 5. Those two things are getting multiplied together, those two expressions, and resulting in a 0. So we could say, what if negative 3n was the thing that was equal to 0 to make the whole thing 0? Let's solve for it. So we go negative 3n divided by negative 3 equals 0 divided by negative 3, and you get n is equal to 0. That's one number that when you plug that value in for n, it results in 0 as a product. Okay? And anytime it's a monomial like you're seeing out front, negative 3n, some monomial with a variable in it, really it's just going to have a coefficient on it maybe, and then you divide by that 0 by that coefficient as well as the expression, and you get the variables equal to 0. What I'm getting at is for something like this monomial sitting out front, it's going to be one of the values is that will turn the whole thing 0 will be 0. Okay? So let's do the second bit of it. And what we're going to do with the second bit is take 2n minus 5, that's underlined in that dark indigo, set that equal to 0. Because maybe that was the thing that was 0, equal to 0, that made the whole thing be 0. So we need to solve for the value in this that would make that expression equal to 0. We get 2n equals 5, and then when we divide by 2 both sides, we get n is equal to 5/2. That's another number that if we plugged it into the top expression, everywhere we saw n, we would end up with a 0. Yeah? Okay. And one more we're going to do here is number 13, and we will take this expression, set it equal to 0. We're going to set that expression equal to 0 in a minute. See what we get. So firstly, 4a minus 7 equals 0. Solving for a. That is a value for a that would result in a 0 output. Okay? Let's do it for the other expression. 3a plus 8 might have been the thing that was equal to 0. That would turn the whole thing 0 when you multiply the two things together. Let's solve for the a value that would make that expression be equal to 0. And we get a is equal to negative 8 over 3. Again, the two values that would turn this expression to 0 if you replaced a with that particular value. Just to be clear, looking at number 13, the one that I just did, you're not allowed to put 7/4 in for a in the first one, and then put negative 8/3 in for a for the second one. Whenever you replace a variable with a value, you got to use that same number, that same value, everywhere you see it. Okay, so we could put in 7/4 in the first and the second place where we see a, or we can put negative 8/3 where in the first and the second binomial where a is. But we can't like plop one number in for a and then a different number in for a in a different spot. It's always got to be the same number. So both of these numbers, like if we replaced a with 7/4 everywhere we saw it, one of the two expressions, the first one, would turn to 0. The second one wouldn't, but that's all you need is one of them to turn to 0, right? And then we could also take negative 8/3 and put that everywhere we saw it, and it would turn the whole thing to 0. Just be careful that you're not replacing a with one number and then later on in the exact same problem, you're putting in a different number. So if you need clarification on that, please check with me. But just know that you're replacing a with either 7/4 or negative 8/3 everywhere you see it, and you're not jumping from one to the other within that same problem. Okay, that's it. That's how you do it. Set each of the binomials or the monomials equal to 0 and solve for the value of the variable that would make that expression equal to 0.